In this video, I'll be showing you how to factor trinomials that have a leading coefficient of 1. This is also a form of a grouping method. So let's go ahead and get started with the first example. We have this trinomial x squared plus x minus 6, and we want to factor this, but because these terms don't have a greatest common factor, we could break up this trinomial as a product of two binomials. So we'll start that off by first breaking up the x squared into x times x, because we know that x times x gives us x squared. Now, to break up the rest of the trinomial, we need to find two numbers that when we multiply them give us negative 6, and the same two numbers have to add to give us this 1x. So let's consider all of the numbers that multiply to give us negative 6. We have negative 6 times 1, 6 times negative 1, negative 2 times 3, and 2 times negative 3. And we need these same numbers to be able to add up to give us 1. And you might be wondering, why do we need these numbers to add up to 1 when there isn't a 1 in the problem? Even though we don't see a 1 in a trinomial, there's a 1 in front of that variable x. So let's see what each of these equal. We know that each of these numbers multiply to give us negative 6 because we chose a set of numbers that multiply to give us negative 6. But now we need to check which of these numbers will also add to give us 1. Let's start off with negative 6 plus 1. We get negative 5. 6 plus negative 1 gives us positive 5. Negative 2 plus 3 gives us a positive 1, and 2 plus negative 3 gives us a negative 1. So the set of numbers that multiply to give us negative 6 and add to give us positive 1 would be negative 2 and positive 3. So negative 2 times positive 3 multiplies to give us negative 6 and also adds to give us positive 1. So those numbers can be put into our product of binomials. Now, would our answer still be correct if we flipped the positive 3 and the negative 2? Absolutely. Multiplication terms can be flipped and they still equal the same thing. So the product of the two binomials x minus 2 times x plus 3 is a factored form of the trinomial above, as well as the product of the binomials x plus 3 times x minus 2. Now let's see how we can check our answer. Using the product of binomials that we got as an answer, we can work backwards and FOIL out the two binomials to see if that gives us the polynomial that we started off with in the beginning of the problem. So I'm going to use the FOIL method, and if you're not sure how to FOIL, we do have a video on foiling. It's called multiplying two binomials using the FOIL method. I do recommend checking that out before this so that you could check your work when you're factoring trinomials. So let's go ahead and FOIL. We begin by multiplying the first term in each set of parentheses, x times x, then multiplying the outer terms, 3 times x, multiplying the inner terms, negative 2 times x, and multiplying the last terms, negative 2 times positive 3. Then we need to separate our multiplied terms with addition symbols. Now we can go ahead and simplify. X times x gives us x squared. 3 times x can be rewritten as 3x, negative 2 times x can be rewritten as negative 2x, and negative 2 times positive 3 gives us negative 6. Now we want to continue to simplify further. X squared is just brought down as x squared. Positive 3x and negative 2x are like terms because they both contain 1x, so those simplify to positive 1x. And then our last term, negative 6, can just be brought down. X squared plus 1x minus 6 can also just be rewritten as x squared plus x minus 6. Because when we worked backwards, we ended up with the same trinomial that we started off with before we factored, that is how we know that our product of binomials that we got as our answers when factoring are correct. Let's do another example problem. We want to factor the trinomial m squared plus 11m plus 10. And because these terms don't contain any greatest common factor, we can factor this trinomial as a product of two binomials. We begin by breaking up m squared as m times m. Next, we want to find two numbers that when we multiply them give us this positive 10, and those same two numbers should be able to be added together to give us this positive 11. Let's consider the list of numbers that multiply to give us positive 10. We have 10 times 1, negative 10 times negative 1, negative 5 times negative 2, positive 5 times positive 2. And these numbers should also be able to add to give us positive 11. We know that each of these equal to positive 10 because we chose them so that the product of them would equal positive 10. But let's see when we add them together which pair is going to give us positive 11. We know that 10 plus 1 gives us positive 11. Negative 10 plus negative 1 gives us negative 11. Negative 5 plus negative 2 gives us negative 7. And positive 5 plus positive 2 gives us positive 7. So the set of numbers that give us positive 10 and positive 11 would be positive 10 and positive 1. Positive 10 times positive 1 gives us positive 10, and positive 10 plus positive 1 gives us positive 11. And as mentioned before, the product of these two binomials can also be switched to m plus 1 times m plus 10. Both of these are correct factorizations of the trinomial above. Here we have extra practice problems that I encourage you to pause the video, try solving these on your own by factoring them using the grouping method. For the step-by-step solutions and answers to solving these practice problems, click here. For more future math videos, please subscribe to our channel by clicking here. If you have any questions that were not answered in this video, please leave them in the comment section below. Thank you for watching.